Hey guys, this is Chris again. Today we're going to do a video on the van, his Ajax. He's very tired today because he had a big day at work yesterday. And he's getting old like the rest of us. Yeah, today we're going to talk about the roof rack and how I built it. And so let's kind of go in here and we kind of see the light. So I'm using a headlight with this, which is not the right way to do this, but it's okay. I'm not a YouTuber and I don't play one on TV either. So this is 1-inch square tubing. You can see I've got planks, cedar planks bolted to it, some weep holes in the bottom, a little outrigger, which is right here, and then flat stock that goes up the side. Mounting points, let's show you the mounting points much closer detail because they're important. Let's do this, let's put some light on this. All right, so that's what the mounting point looks like. That's the back one. And then the middle one I actually didn't use. This is what the mounting point looks like when you don't use it. It's got a little plastic cap. It's a Phillips head sort of slot in the top of it. Unscrew it, and underneath it there's like an 8mm nut that you can connect. You can screw through your, in my case I have it screwed through. This is a much better shot of this. So this is what it looks like. This is, actually let me use a pencil here. So we have a piece of round stock that's hollow in the middle. It's welded here. Don't bust my balls about the weld joints. I'm not a welder. It's a Harbor Freight Tools $99 welder, so you got to give me a little bit of leeway. It's a rubber washer and just a metal flat washer, stainless steel, just to distribute some of the load. And that's how it's mounted. It's 4 of these on all 4 corners of the rack. That should hold everything. Like I say, this is only supposed to be rated for 150 pounds. I know people put like ladders and all sorts of crap up here. I'm only going to use it for mostly plastic totes and maybe some water jugs and things like that. So doesn't need to be a super heavy duty rack. It's mostly to hold the solar panels and sort of hide them from prying eyes. All right, so let's take a look at the, everybody has questions about, hey, how do I get my wires to the roof? Everybody's freaked out about them leaking in the future and all that kind of good stuff. Well, I'm going to show you the right way to do it. And this has been done for decades in RVs and it works perfectly well. So this is this piece of plastic you can get on Amazon. They're, I don't know, 10, 12 bucks tops. It's got a little, this actually rotates and grasps the cable, and there's like a little piece of rubber in there, creates a watertight seal right here. So there's no water's gonna leak in here. Where the water will leak in is from the roof. I'm trying to keep you centered there. So from the roof and the seam that's at the bottom of this. So the way you handle that is there's a product called butyl tape. It's basically like Play-Doh. You just sort of form it into a little gasket around the bottom. You screw this down. I think if you look right there, that's a screw, the screw head poking through. You screw it through, the stuff oozes out just like Play-Doh would. You form it with your fingers, sort of try and make a nice little chamfer all the way around your piece. And then what you see here, let's see if I can get a little higher so you can see it better. I'll give it a little light. So how about that? So you can see this stuff right here. This is called Dicor. It's a self-leveling sealant. Yeah, it's very difficult to kind of see, but this is Dicor. So what you do is after you get the whole thing screwed down, you pour this Dicor stuff on it and it seals it forever, or for 10 years anyway. And in this case, it's probably forever because this is underneath the solar panels and no sun's gonna hit it, so it's not gonna crack and chip the way these things tend to do. So that is, if I can get that focused better for you. There we go. So that's what the through the roof hookup connection looks like. Incidentally, this connection is actually the one I use for my fog lights in the front. As you can see right there, that's the wire that's attached to the strip of fog lights. And I'll go to the other side and I'll show you how the solar panels go through, just in case you care. Okay, so this side is the other side. I can show you where my solar panels go through. Again, this plastic box, it's actually a 3D printed plastic box. There may be an STL online somewhere for this. My solar panel connectors, so this is one of the connectors off the panel right here. And they actually just plug right, they just sort of screw right into this, this little connection here. Go through there and get a little better view of it. And these wires go up onto the solar panels underneath. These 2 panels are actually wired in series, so it gives me these are 12-volt panels wired in series, so it's 30 volts or so that go into the MPPT charge controller that I'm using. And I'll talk about that in a later video. Let's talk about the roof vent. There's actually some things you should know about that. Okay, so here is the roof vent, and I have it open right now. And the first thing you'll notice is this little pin right here. It's actually a switch that turns the fan on and off. So if this is down, actually the fan won't run, so just FYI. And if you look in here, you can kind of get a sense of where you see the leveling compound where I sealed off all the screw heads right in there. Some people are very concerned about cutting through the top of their roof, which I guess I understand. Let me show you this from the inside. You can get a better sense of that. So here's what it looks like from the inside. And first thing you're going to notice, you'll be horrified to see that, oh my God, you've cut through this structural piece. And it's actually not a structural piece. The NV200 has an outfitter's guide that basically says that's not a structural piece. It's really just there to keep the wind from buffeting the roof in the middle. It keeps the roof from vibrating up and down. So you don't need to have it. You can cut through it, it's no problem. I actually used RTV to seal this back up to the roof so these things don't flap around, because they actually would have. So I have this fan, a hole cut through the roof. The fan is there. If I flip my switch, I've got a little switch over here for the fan. This will start up. That's the fan. So this knob here is actually a variable speed controller. You can turn it up, you can turn it down. And then this switch right here is a reversing switch. So right now it's blowing in. It could also suck out air out if you wanted to. Let me tell you a little bit about this. This is a kind of an important thing. This knob, this wasn't stock. So this fan comes in a couple of different versions. One of the simplest versions just has a little switch that lets you switch between high, medium, and low. That is an incredibly inefficient version of this fan. I'm really shocked that they do it. From an engineering standpoint, it wastes a lot of energy, especially with RVs where energy's at a premium. You think that they would do a better job with it, but it's really a terrible way to do it. So what they do is they make effectively wire wound resistors. There's literally pieces of wires they wind up into coils, and a switch switches them in series with the motor to slow it down. And what you do is you waste a bunch of, basically you waste energy heating up those pieces of wire, and it's really a bad way to do it. So what I've done is this is actually a knob. There's actually a little PC board in there that I got off of Amazon for, I don't know, like 20 bucks. And I retrofit, I took the switch out and replaced it with the knob. And it's a PWM, it's called pulse width modulation, which basically sends pulses of energy to the motor to speed it up and slow it down. That is the correct way to do this. And so you can actually buy it with that PWM from the factory, but it's cheaper if you just do it yourself. And since I'm a geek, I just decided to do it. So it looks reasonably good and it works well. So that's the trick with the fan. So I think that's probably all I'm going to talk about today. Give you a few more beauty shots of the rack. Maybe I should give you some dimensions of the rack. So this is 8 feet long. It's got a 6-foot section. This actually was made out of 6-foot pieces of 1 inch by 1 inch square tubing. And I actually had to weld a 2-foot section on in order to make it 8 feet long. If you can find 8-foot tubing, it might save yourself some hassle having to do that weld. The coating on this, here's actually something you should see. Coating on this is actually just spray-on bed liner, which in my opinion is not much better than spray paint, but it does work. I would actually try, there's a product called Monster Liner that a lot of Jeep guys use. You can paint it on or put it on with a roller, and it goes on much, much thicker. I think that would probably be a better approach. And then the other probably tip I would say to do is, if you can, internally coat the tubing with some kind of paint to keep the rust from getting in there. I have weep holes all the way down it, but I think rust is going to become an issue with this at some point. So I probably will spray fluid film in it, which is a rust inhibitor. But if you could paint it initially, that might actually be a good idea. I just was too lazy to do it when I built it. So that's all I got for now. Like I say, more videos will be coming. Ajax, say bye. Bye. Thanks for watching.